Hello guys, welcome to another video. So basically, in today's video we're talking about how to build production-ready multi-tenant SaaS applications in Rust. So let's get into it. So the question is, how do you prevent one customer from having access to another customer's data? This is a problem I had to solve with SmartFarmAI. So what's SmartFarmAI? SmartFarmAI is an AI-powered poultry management application that helps farmers manage their flock, manages farms with beds as low as 200 beds to as high as over 500,000 beds. In this video, I'm going to show you the patterns I used, as well as the row-level security, my schema, the Actix middleware that I used to achieve this very functionality. Let's get into it. In my case, SmartFarmAI serves poultry farms in Nigeria as well as Tanzania. If a poultry farmer in Lagos logs in, they want to see their farms, they want to see their logs for their eggs mortality. If they go on to see data from a farm somewhere in Tanzania, that's not just a bug, that's data violation, and it breaches trust. These farmers are trusting you with their data, and you should do everything to make sure that it is safeguarded. Now, there are three ways to achieve tenant isolation. The first one is database maintenance. In this case, every user gets a Postgres database. This gives you maximum isolation, of course, but it becomes a nightmare at scale. Every migration becomes a coordinated rollout across hundreds of databases. You do not want that. You don't want a situation whereby you have 100 users and you're having to maintain 400 databases. Now, the second one is schema per tenant. So basically what this means is one database with multiple schemas for different customers. This is better than the previous one, where you had different databases for everybody. But in this case, migrations are still very painful. I wouldn't really say very painful, I'll say they're still painful, but then there's the issue of connection pool getting really complicated fast. Then the third one, which is the one I use, is a shared database with row-level security. What this means is one database, one schema, and one set of tables. Then Postgres itself enforces what row each tenant gets to see. So you might be asking, why RLS? It's pretty much simple. RLS pushes security, or it pushes security enforcement down to the database layer. So basically, I don't have to use the where clause in my application where I would say something, where I would do something like where organization ID equals something for every single query. I just write my code that way, and even if I forget to add a filter, it doesn't matter, because Postgres will not return rows that are not that does not belong to the current tenant. Now let's move over to me sharing my screen so I can show you an interactive data model of how SmartFarmAI works. But before we do that, I will just give a little bit of explanation. So basically, there's an organization hierarchy. There's a hierarchy, and at the top of the hierarchy we have the organization, which is the tenant. Under the organization we have the farm. Under the farm we have a batch. This batch is basically like a group of beds, a group of beds in a farm. Then under the batch we have the mortality record, egg record, weight record, vaccination schedules, and all that. Now, here is one thing that most tutorials really don't talk much about. Every single table, even a child table, has a reference to the organization ID. Let me show you.
So this is the hierarchy I was talking about. So you have the organization, under the organization you have a farm, you have a batch, you have egg record, mortality, vaccination schedule. Right, so let's just go quickly to the schema. So looking at the schema, you have the organization table. Under the organization table, we have the farm table. This farm table references the organization ID. We also have a composite unit key for the child foreign key references the organization ID and the ID of this farm. Then under that farm we have batch, the batch references. The batch requires the organization ID as well as the farm ID. But then there is a constraint, right? A composite foreign key that makes sure that we cannot assign a batch to a farm in a different organization. Yeah. So you can see it here. So it references the organization ID as well as the farm ID. Same too for the crate table, the egg production table. It references three of those table IDs all the way down to batch ID. Then we have like a foreign key, that makes sure that you cannot record eggs for a different farm under a different organization to another organization or to another farm and another batch. That makes sense. So one thing is you might look at all this and think, so batches already belong to this farm, and farms already belongs to batches already belongs to farm already belongs to an organization, right? So why duplicate organization ID on the batch table? You might be thinking, okay, this is redundant, right? But it's not. So the first reason is RLS policies need a direct column reference. Postgres cannot follow foreign key chains in policy expressions. So the policy needs to see the organization ID right there on the row it's evaluating. Right? It needs to see it right there on the row it's evaluating. The second reason, and this is actually like the clever part, if you look at the composite foreign key, like in this case, right? Look at this. A batch doesn't just like reference a farm ID, right? It's not just referencing the farm ID. It references the organization ID and the farm ID together. So what this does is that it makes it structurally impossible to accidentally associate a batch with a farm from a different organization. So ideally, the database wouldn't even let you do that. You can see how every child table threads the organization ID all the way down through the composite foreign keys. It feels redundant until it saves you from a data leak. Now, moving on to RLS. So with the schema in place, right, having all the schema in place, which I've just showed you, it's pretty much very straightforward to activate or to run like RLS, which is what I'm going to show you in this section. So enabling RLS is very much simple. And by the way, you can get all this in the link I'll be attaching to this video. Basically, the way you enable RLS is you write alter table for farms. So you enable row-level security. You do the same thing for patches. I did the same thing for egg logs. But then there's a magic, right? So the magic right here is, or before we even get to that, after you've enabled that, the next part is the policy aspect. So the policy basically says, please just return rows where the organization ID matches what is in the current session variable. Because the session variable in this case is going to be app.current_tenant_id. So just return data for an organization ID that matches this particular ID. Ideally, the like I said initially, the magic here is the fact that this is just a key value pair that we set before every query runs. So the PostgreSQL RLS engine uses it to filter every select, insert, update, delete request we make automatically to the application. Moving downward, you can also you can see where I used something called like with check. So what that does is that it's with check basically covers the rights. So if someone tries to insert a row into a different organization ID, Postgres would automatically block it. What that means is that you cannot write data into another tenant's space. So yeah, that's basically how this works. So one thing that's worth mentioning is to make sure that RLS policies are not enforced for table owners or super users, which is something that I would extensively talk about. Yeah, so if your application basically connects to PostgreSQL as a super user, RLS doesn't have effects, like zero protection at download. So your app has to connect as a non-super user database role. This is something I'm going to also really emphasize on.
Now, there is something that you should absolutely take note of. RLS does not work for table owners or super users. If you want RLS to work, you must connect as a non-super user database role. These are the kind of things that works in development because probably you're using a restricted role only for someone to deploy the application to production and deploy them with a super user connection string, and all of a sudden all your RLS are gone. So this is one thing that you should absolutely take note of, so that you don't spend a considerable amount of time looking for something that did not get missing. So by now, I know if you're wondering, is this actually a Rust tutorial or is it a tutorial on Postgres? Yeah, we are here. So we're going to basically talk about the Rust middleware and how Rust and Actix-web play a major role in this whole multi-tenancy thing. So for every authenticated request, three things actually happens. The first being where we extract the tenant ID from the JWT. Then we set the Postgres session variable and we clean it off. It gets cleaned out after every request comes to an end. Now let me take you over to my screen so I can show you my code.
Now, like I mentioned, this is where Rust and Actix-web comes into play. Like I mentioned, every authenticated request needs to do three things. One, extracts the tenant ID from JWT, sets the Postgres session variable, like I mentioned. Then after that, make sure it gets cleaned up when the request ends. So the first thing here, is to create a new type wrapper around the tenant ID. So you can see this is a tenant ID extractor. The first thing is to create a new type wrapper around it. So this is new type, new type wrapper around it. So this is one of those Rust patterns that seems like an overkill until it saves you. It's basically a wrapper around the UID, but it means you can never accidentally pass a user ID where an organization ID is expected. The compiler will help you catch this as compile time, not at runtime in production. So it does it at compile time. The next aspect is where we then do like extracting. So in my case, I implemented an Actix from request traits for the tenant ID. What this does is that it automatically extracts the tenant ID from the JWT claim on every request. I mean, you can absolutely go crazy with this. My implementation is way more complex than this, but this is like a basic idea of how it works. So ideally, if there is no valid tenant context, it returns, in this case, returns a 401. You don't have to think about it, in every handler, it just happens. Then the next one is the RLS middleware. So this is like, the core of the entire system. So this is the set RLS function. It takes a database pool, as you can see, and the tenant ID. In my own implementation, which is actually more, advanced or complex compared to this, mine also takes like a user ID, but this is, this would still work depending on the context of the application. It takes, in this case, it takes like the pool, which is the database pool and tenant ID, and then it starts like a transaction. So pool.begin, starts a transaction. Then it sets then it calls the set config to set the app.current_tenant ID. Alright, so it does this current ID to the current tenant ID that we set. So this tenant ID that we passed, so it does that. So now you can also see that there is a third argument here where we set it to true. So that's one of the most important boolean in the entire code base. What this true means is that this particular the particular session is going to be like, it means transaction local, basically. When this transaction commits or rolls back, it automatically clears out that particular tenant ID so that we don't get to reuse it in a different tenant. I explain this in details as we go down the video, but this is a very important aspect. If you set this to false, what happens is after a particular request is made for a particular tenant, if let's say tenant A makes a request and this is set to true, this is set to false, it doesn't clear out the tenant ID or the organization ID from that business scope because it's now session based. So when tenant B comes along, or organization B comes along and makes a request, it then reuses tenant A's ID, which would in turn lead to a data leak. So this is very important that it always sets to true. Then finally, you can now see the handler code and see how it's used. So with everything in one place, you can now see how clean the route handler becomes. So you put the pool and the tenant ID, you call and you set the RLS context, and then you just write your queries, right? So in this case, I just did a simple select ID from farms. I did not have to use a where clause here, so there's no organization ID filter. RLS automatically handles it here for me, and then after everything, I have to commit that transaction. So basically, the farmer in Lagos only sees, like our hypothetical example, the farmer in Lagos only sees their farm, while the enterprise operation in Tanzania, their own data is invisible at the at the database layer. given that they use the same database.
Now let's talk about things that you have to absolutely watch out for when it comes to connection pool. This could actually save your projects. This is one of the things that gave me serious headaches when I was dealing with this. Now, Postgres session variables, they last for the entire life. They persist, by the way, for the entire lifetime of that connection. So when a connection pool is used, they can get reused for other requests. So now let me walk you through what happens when you set your tenant variable to be session scoped instead of transaction scoped. Now let's say we have two organizations, organization A and organization B. Let's look at what happens with organization A. Organization A comes in, makes a request. We look for any available connection pool, let's say connection pool number 5. We check it out. We set the tenant ID for connection number 5, connection pool number 5 to the organization ID of organization A. The query runs, everything goes smoothly. We return the data for organization A. Everybody is happy. Now, a request from organization B comes in. For some reason, the pool hands out connection number 5 again. But here's the thing. The previous tenant ID that was set to organization A was not cleared. The query goes ahead to run, returns data of organization A to organization B. Now that's the problem. We have a data leak. The worst part about this bug is that you probably not even find it in development. And it's simple because you're probably the only one hitting your dev server. You don't have multiple tenants, right? So you probably will not see this in your development process. Another thing again is that it's intermittent, in the sense that the pools are randomly handed over to you. So it's probably very difficult for you to replicate, or it's very difficult for you to reproduce this issue. So good luck trying to debug this in production. Now let me give you a real production story. Ideally, SmartFarmAI uses an outbox, or something called an outbox pattern. So what this means is, you make a request. For instance, you try to record egg counts. We immediately take that data, we insert it into a table, and in that same transaction, we record an event on a Postgres table. Then later on, background workers come along to pick it up and process it, probably carry out AI predictions, update the general record, just do something like on the side. Now I did something funny. I enabled RLS for this particular outbox table, and I set an organization ID for it, because why not, right? Why not protect this particular table? Then the worker started running. It's funny. 0 events got processed. Everything was just silent. I checked the table. All these events were sitting there, not being run, no error, no nothing. It took me an embarrassing amount of time to kind of figure out what was actually happening. Yeah, these workers had no, they had no tenant context in them. They were basically infrastructure, right? There was no JWT, there was no request, there was no user ID, nothing. So basically, RLS was doing what I asked it to do. So basically, was looking at every row and checking for, a tenant ID or something, and just basically filtering out everything. Now, to wrap it up, I'll leave you with some key takeaways. Number 1, always add organization ID to every table, and always use composite foreign keys. Even though it might feel redundant, just do it. Number 2, avoid using session, scope when you set your RLS. Always make it transaction scopes, so that this way, your IDs or tenant IDs are automatically cleaned up for you, and it prevents like a data leak between organizations. Number 3, always write tests that can create like 2 organizations and make sure that there is no data leak between both of them. The 4th one, not all tables require RLS. That's something I learned the hard way. For structural tables that workers need to perform tasks across different tenants should not have RLS enabled. One thing I'll leave you with is, multi-tenancy, multi-tenancy and isolation, data isolation isn't something that you get mostly right. It's something that you absolutely have to get right. It has to be airtight, right? In my opinion, it's in your best interest for you to push security as far down the stack as possible, down to the database layer. My name is Chinedu. I would repeatedly and continuously make videos like this. If you enjoyed this one, please let me know in the comment section. I will also be adding the link to the actual article that's actually well detailed compared to these videos. And if you have like a different approach in how you implement multi-tenancy, I'd love to hear how you do yours. Thank you, and bye for now. Peace.